Now we'll see non-inverting amplifier file, new project, Pspice analog or mixed analog digital, button name op amp, create a blank project. Then we will see all the components. We'll place each and every component. Place. First we'll place the op amp. We'll place it from place piecewise component discrete op amp. If you press right click, you can end this mode, and if you double press it, you can see the details of it. If you double press, it will open the schematic of the op amp. It will show here you can see V negative and V positive. It is plus and minus 15 volt. It is already fixed here, so we don't need to change that in this op amp. Then close it. We need three resistors. We'll take that one place pieces component resistor. And more. We'll connect using wire. Press W for wire. You can see the diagram. To the right side, you can get the ground option. We need three ground. Next, we need the source. Is source voltage source. We need a sine source. I send the circuit diagram before itself. Now we will give the value for each. This is 10k. You can keep whichever value you need according to the gain you wish to change. V of 0 or 0. You only need to give the values for it. I'm giving 500 milliwatt, 500 amp. Frequency is 1k. AC AC you don't need to worry about that. Just give it 0 and then we will measure the. We need to create the simulation profile. Here it's the new simulation profile. Creating name, give open. We need to change the simulation settings. Here is the time to run is 1000 nanosecond. We'll change to 10 millisecond. That's all. You don't need to change anything. The maximum step size, if you want, you can give 1 millisecond. Okay. After you fix that, first you give this opening in voltage measurement. After placing it in input and output, run this. This is the output of non-inverting amplifier. We saw non-inverting amplifier. We'll see the inverting amplifier. For that, I'll create a new. For that, I'll create another page in schematic. If you press right click, you can right click in schematic and get new page. I'll give page 2 itself. In page 2, you see the non-inverting amplifier, inverting amplifier. I'll copy non-inverting amplifier to that one. Control A, Control C, same as others. After we copied it to new page, we will change the circuit to inverting amplifier. For that, this should be. That's all I think. And paste this. Mm. After placing, we'll run the same simulation profile. Before running, we should delete these two knob, knobs here. Otherwise, this will also come in the graph. After placing, we'll run it. That's it. Yeah, this is the output of inverting amplifier. You can clearly see the input and output. Red is input and green is out. Check. Red is input and green is output. Okay, we finished this one. Okay, now we'll see the adder and subtractor circuit. For that, I'll make another page, new page, page 3. Getting into page 3. First, we need an op amp, place Pspice component, discrete op amp. After placing this, I need 3 resistor. I'll place that also. B. I need two sources. I'll go with DC sources. This plus component source, voltage source, DC. I need two of that also. We need three ground. We will get ground from right side or from base part, whichever you wish. Connect the wires. Need one more ground. After placing everything, you can change this DC value. You'll give V input. One input as 3 volt, and second one is 2 volt. After placing everything, this all is 1K, 1K, 1K. We'll measure it. I'll place the props. After placing everything, we'll check the output. Run it, same simulation profile, no change in anything. Here we can see 3 volt, 2 volt. Here is the minus V1 plus V2, which is minus 5. The clear, you can see the output has come clearly. This is the required output. Okay, now we'll see the subtractor circuit. Only some changes are required. I will make in this adder circuit itself for time being. You can undo using control Z. We need one more resistor. I will place it. This is the required subtractor circuit. We will see whether the input comes or not. Yeah, I think the input came correctly. 2 volt and 3 volt. The input has come minus 1 volt. V1 minus V1 minus V2. It has come minus V1 volt. So this output also correct. We will see integrator and differentiator. For that I'll place op-amp plus op-amp and two resistors. Here one. We need one capacitor. Then we need ground. If you press G, you will get the ground directly. We need two grounds. Then we'll connect this. And then you should be careful because you need to place the square wave for integrator. Pspice command modeling application, sources, independent sources. Here you can see square. We should change this time period to 1 millisecond. This +5 and -5. Place it. Connect the source properly. Give the values here. Sorry. Here 10K. Here 100K. This is zero point 0.1 micro. We'll use U for micro. After you give all the values, just check the output. Here one, here one. You should be careful with one thing in your simulation settings. I'll show one thing. We skip initial transient bias point calculation. Skip BP should be ticked. Otherwise, some error will come. I don't know what is the error, but error will come. You will not get the output correctly. There is some error. You'll see what is that. Yeah, you should mirror this vertically. Make sure that inverting pin is correctly placed. We'll run again. This one is the output of integrator. You can see how the triangle square wave has changed to triangular wave. Now we'll see the differentiator. I copy that integrator circuit onto another page. I'll change this to means differentiator. Current source. We'll keep AC source. Sorry, not AC. Source. We'll keep sine source. That we already changed these same values. I'll give 5 volt. Frequency 1 kilohertz. AC will give at 0. This resistors value should be changed to 150 and 1.5k. That's all. If you'll see whether it runs. We need to create an simulation setting. Use some name. Then make sure that you give this skip BP. We'll give 10 microsecond, millisecond. Okay. After this, we will try to run it. Yeah, now you can see this is the input. This is sine wave. This is cosine wave. Cosec wave. Okay, guys, we'll do the frequency response experiment. For that, the procedures are somewhat different. So make sure you are totally into this. First, we'll play 741 IC. We'll place a 7, LM741 IC. After that, I'll mirror it vertically so that inverting pin is above. Then we'll place an AC source. The source, what is source? AC. Give it another 100 milliwatt or something. Sorry, based current source. Base source. AC. Give it some 100 milliwatt or something. Then we need 3 resistors. We'll give that. We need 3 ground. We'll connect it. We'll change this to 10k. Now we need to give the values, means the plus VCC and minus VCC. For that we'll place two DC sources. After placing DC source, we'll connect it. We need a ground. After placing that, we'll change this to 15 volt. This to minus 15. After placing this, we need to connect this point to here and this point to here. For that, we'll place some power points, means VCC. It is the right side, the tool side. Press R and rotate it. We need this sum, so we'll leave wherever necessary. I'll say the uses after some. After making this, I'll change these names. This is V plus. I give us V plus plus for just knowing. This is V minus minus. This V minus minus should be come here. So this is V minus minus. You only need to label it to connect both. This is V plus plus. Now I think the connection is almost ready. We should mark this one also. This is V out. V out 2. I'll give V out 2. This is V in 2. Now everything is set, I think. So we need to change the simulation profile. In that, change the time domain to until now we got no time domain. Change to AC sweep or noise. Then start frequency is 0.1 1 mega. Points per decade equal to 10, means how many points you need. Okay, we'll see whether it works or not. We'll see whether I place any props anywhere. Otherwise, it will come in that graph. So we'll use the option of add trace. We need to find the gain. So we will find out the gain. We gave V out 2. We should find out that V out 2 divided by V into, we will give out the gain. Yeah, this is the desired output of frequency response of op-amp. So we did all the 7 experiments. If you have any doubt in this, you can ask me.